Okay, I'd like to start lesson 2, graphing absolute functions, with graphing the line, the function y equals x. So if we were to graph y equals x, I know that my inputs, my x values are my inputs. If my input -3 into my function, my y value is still -3 because of course y equals x. My input is -2 for x, y is -2. If my input is -1, y is -1, and so on. Okay, I'm looking at the coordinates at the points. Okay, we could also graph this from a Math 10 perspective of looking at the equation of y equals mx plus b. Okay, and if we were to think of it as y equals mx plus b, then we've got y equals to 1x plus 0, where our y-intercept is 0. Okay, and our slope is 1 over 1. Okay, so we could graph it like that as well, but I'm looking more specifically at the points. So let's graph that line. Let's give it a sketch. We know that it goes through our origin. Okay, our slope is 1. And we just sort of draw that line. It looks like that. Okay, now let's look at graphing the function y equals the absolute value of x. Now I know this is a function. Okay, keep in mind for Math 10, anything that can be written as y equals, anytime I can put something in my calculator as y equals, if I've got an equation that starts with y equals and I can throw it into my graphing calculator, that's a function. Okay, that's why when we think about something like x equals 3, which would be our line like this, 1, 2, 3, right? Here's x equals 3. Definitely not a function. A couple of reasons why. I know it doesn't pass the vertical line test, right? For every value of x, there must be one and only one value of y. But that's not the case here. This would be like 3, 1, and this would be like 3, -2, and down here I've got 3, -6. So for every value of my input x of 3, I've got infinite values of y. So that's definitely not a function. And it can't be put in my calculator, right? X equals 3, not a function. Okay? Sort of just something that comes up every here and then. Okay, so let's graph y equals the absolute value of x. My input here, if my input here is x, and I want y equals the absolute value of x, let's put those same values. Let's use our -3, -2, -1, 0, 1, 2. And so let's put the absolute value of -3, the absolute value of -2, and so on. Okay, I'm just going to fill this in here. Oops, I keep making those look like brackets, which they are definitely not. And the y equals absolute value of 2. The absolute value of -3, my x input is not changing. Okay, so if I think about this function, when I put in my x values can be negative, but y is the absolute value of -3, which would be +3. And my input -2, when I take the absolute value of -2, my input, I get a +2 and a +1. Absolute value of 0 is 0 and 1 and 2. So if I think about that, my x coordinates haven't changed at all. So our domain will not change at all, okay? The domain remains the same, okay? But our y values, in fact, will change. So let's just look let's just look over here, down here, at the values where they're the same, okay? Those are all invariant points, right? These points are invariant. They do not change, okay? Invariant means they simply remain the same. They do not vary, okay? So let's graph those invariant points. They start at 0, 0, and they go up. So I'm just going to draw a line sort of right beside this line. Whoops. I know it would be overlapping. Whoops, I guess. Let's just draw it sort of beside more. It's really wanting to pop on there, onto the grid. So I'm just gonna not make it as straight, but there's those points are invariant, okay? And I also know that it's the y coordinates that are changing, okay? All my x coordinates are the same, but it's the y coordinates. So if I look at specific points, for example, this -3, -3 down here, -3, -3, my corresponding point on my absolute value function is -3, +3. Okay, -3, +3. So it's important that we recognize that it's really the y values that are changing. Okay, it's the value of the function or the y values. So this -2, -2 becomes -2, +2, and so on. -1, +1. So we've got this function that actually reflects over the x-axis. The x-axis acts as a mirror. So here's our graph of y equals absolute value of x. And the graph of y equals x was there in blue. The domain doesn't change. So it's the set of all x such that x is all reals. And now the range indeed does change. The set of all y's, y is greater than or equal to 0. But it's really the y coordinates, okay, that change. So in order to graph this function of y equals absolute value of x, the first thing we're going to do is we're going to graph the original function, okay? Then we find the x-intercept, okay? And if you look at where the x-intercept, the place where the graph reflected was right at 0, 0, okay? And then we reflect over the x-axis, okay? We reflect the negative y values over the x-axis. That's pretty much how we're going to do all of these. So let's do this next example. I'm going to start by graphing. Okay, let's graph y equals 2x minus 3. And I can do that in the math 10 sort of idea using -3 as my y-intercept. Okay, I'm not going to look at specific points here. I'm going to go up 2 over 1, up 2 over 1. I've got a couple of points there. And there's my graph, y equals 2x minus 3. And now the point of intersection, or the point of the x-intercept there, I should say, if I want to find my x-intercept, okay, let's find the x-intercept. So that's what it says to do first. Let's find the x-intercept. And of course, the x-intercept for both functions will be the same, okay? So I'm going to let y equal to 0 to find that x-intercept. I add 3 to both sides, divide both sides by 2, and x is 3 over 2, or 1.5. Okay, so here's 1.5 and 0, that's my x-intercept. And then to graph this equation of, or the y equals absolute value of 2x minus 3, what I want to do is I'm going to find a couple of points. For example, my y-intercept here of 0, -3 is going to become 0, +3. Right, because it's those y coordinates that indeed will change. I know I've got the point here 1, -1. And the corresponding point, therefore, will be 1, +1. And all I need is a couple of points, and I've got my equation, my graph. Okay? And then, of course, there's this overlapping. These are all invariant points here. Okay? Invariant points. Okay, those are all overlapping or invariant points. So here's our new graph in black. This is the y equals the absolute value of 2x minus 3. Okay, so that's all there is to graphing these. Determine the slope and the intercepts. So our x-intercept was 1.5. Our y-intercept was 0,3. Or we can say 1.50 if we want to. I'm going to put those. It's the y-intercept that became positive. Okay, it was negative, became positive. And the slope, well, what is the slope? The slope was 2 from this point on. Our slope was 2, a positive 2 from this point of our graph on, and our slope was negative 2 to the left of that x-intercept. So we can actually say that our slope is 2 when x is greater than or equal to 2, and our slope is negative 2 when x is less, sorry, and that's not 2, I apologize, when x is greater than or equal to 1.5, the x-intercept, and our slope is negative 2 when x is less than 1.5. And some of you might be wondering, where do you put the equal sign? The equal sign goes with the overlap, okay? I put the equal sign with the overlap. So over to the right here, this is where x is greater than or equal to 1.5. And over to the left, we've got x is less than 1.5, okay? I put the equal sign with the overlap there. So there's our slopes, and there's our x-intercept and our y-intercept. So I would strongly recommend that you try this graph. I will complete this for you, but why don't you pause the video and try this on your own. Okay, so if you took the time to graph this function, you would have graphed y equals 3x plus 1 first. Then the next step would be to find the x-intercept by letting y equal to 0. Then you find a couple of points down below the x-axis, reflect them over the x-axis, and draw the line. Okay? And our slope there was a positive 3 on the right of negative 1/3. Okay, because that's our x-intercept here, which was negative 1/3. So to the right of that value, our slope is positive 3, and to the left of x equals negative 1/3, our slope is a negative 3. Okay, our domain doesn't change, and our range is y is greater than or equal to 0. Okay, so that does indeed change, but those are your domain and range. Okay, so hopefully that makes sense. Let's look at the very next question. We're going to do the exact same thing. We're going to graph the absolute value of a parabola. So the first thing I want to do is, it says find the y-intercept, the x-intercepts, and the vertex. So I can see right away that when x is 0, y is equal to 8. So we can identify our y-intercept. I'm going to start again by graphing the original function, y equals negative x squared plus 2x plus 8. So when x is 0, y is 8. I know that right away. And let's find our x-intercepts. If I want to find the x-intercepts, I'm going to let y equal to 0. Here x was equal to 0. So if x is equal, if y is equal to 0, we've got our negative x squared plus 2x plus 8. We need to factor that one. And the first thing I want to do is I want to get rid of this negative. Okay, I don't like to start with a negative x squared. So I don't always show this work because we can just know that we're doing that. Dividing everything through by negative 1, which basically the shortcut is we would just make this a positive x squared and a negative 2x and a minus 8. All the signs change. And I can do this easily and quickly because this is a 0, right? 0 divided by negative 1 is still 0. Now I want to factor, if I can, to find the roots. If I couldn't factor, I would use the quadratic formula if I needed to. But this is easily factorable. Factors of negative 8 that add up to negative 2. I've got an x minus 4 and an x plus 2. So x is equal to 4 and x is equal to negative 2. Okay, so let's graph those. -2, and 4. And I also know that this parabola opens downward because it is a negative a value, right? A is -1, so it's going to have a maximum. And if I could find that back maximum, I could do that finding the vertex. Now keep in mind, you'll have a graphing calculator. I'm going to do this without, I'm going to draw without a graphing calculator. And I'm going to review one question here with completing the square. Okay, when we do the next one down below, we won't complete the square. We'll use our calculator, but as a little review as well. But let's just find our vertex by completing the square. We've got our y equals negative x squared. Sorry, no brackets there. We can take that out in a second. Negative x squared plus 2x plus 8. And the first thing we want to do is take the negative out of the first two terms. We're factoring out that -1. And we've got an x squared minus 2x. 8 comes out. And I want half of -2 squared, right? Or half of our b value squared. So -2 divided by 2 squared, which is of course -1 squared, which is 1. So we're going to add 1 and subtract 1. And we get a -1 x squared minus 2x plus 1. This -1 comes out, but before it comes out, we need to multiply it by this -1. So we're going to add 1 to our value of 8 to give us a maximum there of 9. Okay, so when we factor this perfect square trinomial now, we get an x minus 1 squared plus 9, which means our vertex is +1, 9, and our a value is -1, so we can graph that quite easily. 1, 9, it's right there. And of course, if that's my vertex, I also know my axis of symmetry is right there, so I'm going to have another point right there. So let's just, now we have enough information to sketch our graph. If I wanted one more point, actually, come to think of it, I know I can go left 1, down 1, left 2, down 4, which would take me right there, and there would be a corresponding point there. And then I've got left 3, down 9, right? This distance from here to here is 3 squared, which is 9. And if I were to move from my vertex left 4, that would take me to -3, and I would go down 4 squared is 16. So I would go from -3 down to -7, because 9 minus 16 is -7. So I know I've got this point here, and I've got a corresponding point over on the right hand side of 5, -7. And this is -3, -7. Now I could find this all out with my graphing calculator as well, so keep in mind that you're always going to have that on your test. You can find these points there. Okay, but there's our original function of y equals -x squared plus 2x plus 8. And now what I want to do is I would like to graph the corresponding absolute value function. So the same thing as before, I've drawn my graph, I have my x-intercepts, I find a couple of points down below, and I reflect those up, because it's the y-coordinates that we take the absolute value of. The inputs do not change. Our domain stays exactly the same. So in fact, our domain is going to be all real numbers, and our range is going to be greater than or equal to 0. And I'm just going to reflect those points up. Okay, in green, this would become 5, 7. And this would become -3, 7. And those branches will reflect up. And of course, we've got this middle portion where we've got invariant points. Okay? So our original graph was in blue. And we've got these invariant points all in the middle here. This section Okay, we could just label those if we wanted. These are all invariant points. Okay, and I'm going to do this on the same graph. So this green portion is our y equals the absolute value of negative x squared plus 2x plus 8. And the blue was, of course, y equals negative x squared plus 2x plus 8. Okay. Verify with the graphing calculator. You can do that if you would like. Okay. I would try this one more time, but maybe we'll just do this together quickly. The y-intercept right away, if I were to graph y equals x squared minus x minus 2, the y-intercept is negative 2. When x is 0, y is negative 2. Our x-intercept, I'm going to try factoring, which we can easily. Factors of negative 2 that add up to negative 1, x minus 2, and x plus 1. So x is equal to 2 and x is equal to negative 1. So right away I know a few things. I know that x is 2 and negative 1, and my y-intercept is negative 2. This is of course an upward facing parabola because our a value is positive 1. If I was using a graphing calculator and I was on a test, I could easily put this in my graphing calculator and find the minimum, right? We can find that minimum, right? Left bound, right bound, find the minimum value using our calculator. Quickly, probably before I can get my calculator out, I know that my axis of symmetry here, right away, I know my axis of symmetry is going to be the average of those two x-intercepts, because those are the axis of symmetry is in the middle. So if I take negative 1 plus 2 and divide by 2, that's going to be a positive 1/2. So I know that my axis of symmetry is along the line x equals 1/2. So if I know that my axis of symmetry is along there, I know my vertex is on there as well. So I'm going to just quickly plug that into my calculator, okay, or into my equation. If x is 1/2, then y would equal to 1/2 squared minus 1/2 minus 2. 1/2 squared, that's 1/4, minus 1/2 minus 2. That's 1/4 minus 2.5. So that's going to be a negative 2.25. Okay. 0.5 minus 2.5. Sorry. Why did I write 1/2 there? Sorry, guys. That's 1/4 minus 2.5. So 0.25 minus 2.5. Negative 2.25. Okay. So I just plug those values in. I could use my calculator as well. So then I know my vertex is 1/2 and negative 9/4, or negative 2.25. Okay, so let's find that value. Let's plug that in. Negative 2.25, that's really not much lower than my y-intercept, right about there. And since our a value is 1, okay, it's just not a nice number in terms of because it would be over 1 up 1, which would be kind of a decimal, right? Over 2, we're kind of not perfectly on the grid there. So I'm not going to draw it perfectly. I'm going to do this. There's our original function, y equals x squared minus x minus 2, excuse me. And I know if my vertex here was 1/2 and negative 2.25, I know that my corresponding kind of summit will reflect to be 1/2 and positive 2.25. Okay, so I'm just going to do that maybe in purple here. This would be 1/2 and 2.25 positive. And my y-intercept, instead of being 0, negative 2, will be 0, positive 2. And my graph will look something like this. And of course, these are invariant points. Right, there is our corresponding graph. Okay, the domain and range. The domain would be, of course, the same because our inputs are not changing. It's just the absolute value of our outputs that we're taking, right? So it's really our outputs that are changing. X is all reals. Y is greater than or equal to 0. And there we have it. So if you're looking for which questions to do, I don't think you need to do all of them. If you want to do all of them for extra practice, go ahead. But I think at a minimum you should do these questions down below. 1, 2ACE, 3AD, and 4AB. Good luck, and if you have any questions or concerns, please do not hesitate to contact me. Thank you.